So in our previous video, we graphed sine, cosine, and tangent functions. And in this video, we're going to do translations of those. So we're going to move them and see what happens. So our learning target is I can translate trig functions and find key features. Okay, so in the little box right here, these are kind of like your rules for transformations. We've transformed a lot of functions. Probably haven't done a lot of trig functions. That's what we're doing now. So, like other functions, trig functions can be translated. Given the functions to the left, or right above, that circle in green, h is going to represent a horizontal shift. So remember, horizontal, moving it left to right. So that letter h right here is going to represent a horizontal shift. So inside the parentheses, if there's a number, it's either moved to the left or right. And we'll talk about what that number would do. Okay, when I'm talking about k in those formulas, that's your vertical shift. So that's your up or down. So that's the number at the very end. So if there's a number at the very end, outside of the parentheses, then your function has either moved up or down. And here's how you can tell. If k, which is at the very end, if k is positive, then that's a vertical shift up. If k is negative, that's a vertical shift down. Oh, I should have done these in red. My bad. Up, down. Your horizontal shifts, which are from left to right, if h was a positive number inside that parentheses, that's when it moves to the left. And if h is a negative number, it would move to the right. Okay. So if you look at the first one, if you had the cosine of x plus 2, so you added a number to the very end, that's k. Because it's positive, it would move up 2. Alright, if you look at the next one, f of x equals tan x minus 1. Minus 1 is a number at the very end, so that's a vertical shift, and because it's minus 1, it would be down 1. Alright, so the next one, sine x plus n over 2. So a number inside has changed, so that's your horizontal shift. Because that number inside is positive, it would move left pi over 2. And then for the fourth one, cosine x minus 1. So inside the parentheses, you have a minus. That would mean it goes to the right pi. So those are your things that can happen. So at the very end, if a number's at the very end, it's either going to move up if it's positive, down if it's negative. If a number changes inside the parentheses, it's going to move left if it's positive, right if it's negative. That's what you're saying with these rules. Okay, something else that we'll talk about when we're talking about transformations of trig functions is called a midline. So shifting a graph vertically will create a new horizontal axis called the midline. That's what a midline is. It's whenever you have a new horizontal axis. This is the reference line to which a graph oscillates. So it's making that wave. That's called oscillation. It's oscillating. The equation for the midline is y equals k. Alright, so here's what it would look like in the very beginning. So that's your sine of x. So notice that something has happened. It's moved up 4. So my new midline will be y equals 4. So if I were to graph this, my new horizontal axis will be right there at y equals 4. That's what it's talking about. So it's just moving a graph and then stating the new midline. Okay, so if we look at this one, remember the original graph would look like this. Okay, so I want you to graph the new function, this one right here, and sketch you a graph. Do that in 1, 2, 3. So something like this will do. Okay, Remember, we find the amplitude by doing the number in front of sine or x and then making it always positive. So my amplitude is 3/2. Remember that period is 2 pi divided by the absolute value of b, and b is the number in front of x. So we haven't understood 1 in front of x, so 2 pi divided by 1 is 2 pi. Phase shift, none, because there's no number inside of a parentheses beside of x. But vertical shift, we definitely have one, because we have this plus 3 at the end. And notice that it moved up 3, so we would say up 3. So the new midline would be at y equals 3. And that line would be right here. It would hit the y-axis at 3, that's why it's y equals 3. Okay. So let's do this next one. Remember, my original parent function would be f of x equals tan. Alright, so here's my transformation. So go ahead and pause the video and sketch your graph in 1, 2, 3. So something like this. Remember, the tangent graphs are the weirdest ones. So amplitude, remember, we don't have an amplitude when we talk about a tangent graph. The period is a little bit different. Here's the formula for period. But it is still the number in front of x. So we only have a 1 in front of x, so pi divided by 1 is just pi. Phase shift, that's when you have something inside the parentheses happening. So we do have a phase shift this time. And because it was a plus, remember that moves it to the left. So we would say left pi over 2. It does not have a vertical shift because we don't have a plus or minus at the very end after the parentheses. So I'd say none. And then because it did not move vertically, our midline would still be at y equals 0. So our midline didn't really change. Okay, and then let's do this one. So my parent function would have been this. Alright, so go ahead and sketch a graph, and then we'll look at the key features. So try that in 1, 2, 3. Okay, that was not fun to draw at all. Okay, so remember, amplitude is the number in front of sine or in front of cosine, and it's always positive, so my amplitude is 3 this time. Period is 2 pi divided by the number in front of x. My number in front of x is 4, and I can reduce that because 2 divided by 4 is 1/2. So my answer is going to be pi over 2. There's definitely a phase shift happening because you have inside the parentheses a number. Remember, if it's minus, that moves it to the right. So move it to the right, pi over 2. There is a vertical shift because you have the minus 2 outside. So I would say down 2. And if it's moved down 2, the new midline will be y equals -2, which is about right there. Okay, so that's how you do those key functions of a graph. Let me know if you have any questions, if you're having trouble with the formulas, anything like that.